In this video, we're going to have a brief look at Linux kernel vulnerabilities. Now, as we said before, the Linux kernel consists of over 19 million lines of code. So there is a good possibility that within those 19 million lines of code, you might find some sort of errors. Now, in this video, I really wanted to go over something that is a little bit different, how Linux handles what we call system calls. So, in the Linux world and then the Unix world as well, if I want to call a standard operating system function, I might be using a library, as you would do, say, in Windows, to call the function. And in most cases, ultimately, there is an underlying function that's being called. So, this underlying function is going to use a system call. And essentially, what a system call is, it's a set of standard function calls that have each of them assigned a number. And you load the appropriate parameters and you make the system call. It is executed in kernel mode in ring 0 with elevated privileges. And then it returns back to user mode space in your program. So what I've done here is I've written a very simple assembly program. Now this one is 64-bit that demonstrates how this works. And this is essentially a hello world program for 64-bit Linux assembly. So I start out by defining a global for the start _start. And this is used by the operating system to find where it should begin executing. And I also define a text section. The text section is typically what's used to store my program. Here's my label, start. And I want to write out to a file. Now in Linux, everything is a file, and that includes standard out, the console screen. So the system call number for the write command is 1. So I take that number and I move it into RAX. And then if there are any parameters to my system call, I put those in various registers. And there's an ordering for these registers. It's not terribly important for you to understand the ordering, but just realize that unlike the normal function calls we've talked about a lot in this course, where things are passed on the command line, here, things are passed through registers. So I use the RDI register to tell it what file handle, and file handle 1 is standard out. File handler 2, by the way, is standard error. And I say I want to print something or write something to that file. The next parameter I give it is what I want to write, followed by how long it is. I use syscall to invoke the system call, and then my program should exit and return a value. The system call for exit is 60. Move it into EAX. I could have used RAX as well. I want to return 0. Here I did something a little different. I actually exclusive ORed the register with itself, which makes it 0. This is something we'll come to later when we start talking about exploits and exploit development. It's a common thing to do to avoid having zeros, which are interpreted as nulls in shellcode. And then we call that system call. Down here, I have a label for message. Under that label, I've said, please define some bytes. That's what DB stands for. And here's a string, hello, comma, reverser, exclamation point. 10 is the ASCII code for a new line. In some cases, you would use a \n. In this case, I'm using 10. What I've done on the next line is actually a little trick that you can use. If you don't want to constantly calculate the length of something, you can do something like this. You define a label right after that thing. So right after message, I've defined len, and I've said this is equal to $. $sign is the current location minus message. And the difference between those two memory locations is, of course, the length of this message. So that's my 64-bit assembly program. I can go to my command prompt and I can compile it. So if I want to compile this, I can use GCC. I can also use NASM and tell it my output format is going to be ELF64. And I would like to compile simple.asm. And I want my output to be simple.o. Now I need to link that file. And I use the linker, LD. I say, please link my file simple.o, and the output will be simple. Now, if I run simple, there you have it, my first 64-bit Linux assembly program. I've written a small program that is going to use a system call, which is executed in the kernel of the operating system. We'll take a small break. When we come back, we will talk more about assembly and system calls.